Hey guys, welcome back. This video is all about the modification of the cheap €1 LED light. It starts with some sped up footage where I try to figure out how everything will come together. But for now, enjoy the video. So this is how far I am after several hours of work. I've got the USB charger in the remainder of the battery box, which I need because of these spikes for the switching mechanism of the LED. Got the mains cable directly connected to one of the connectors for mains voltage, and the other one is really long. I got the bottom part. The battery compartment is now glued shut. I glued in a piece of cardboard so it looks white on the back side and the PCB is not sticking out. This is a DC to DC converter. You may already guess it, but a USB charger gives 5 volt and the LED maximum needs 3 volt, and now I also know that the batteries were not connected in parallel but in series, so it seems like the LED needs 3 volts, but we will take a look at the LED after I explain everything and started to assemble it. So the bottom part has now the DC to DC converter installed, a cutout for the mains cable, another cutout for the mains switch. I will use this one as a main switch. The power supply and the mains cable go in like this. The red cable will be connected to one side of the switch and the brown cable gets connected to the other side. There are just two things that I don't like. For one, the remaining mains cable goes over quite a few of these components. Yes, they are still main side, but I don't like that. So I designed a small shroud that I will glue on top and will separate the brown cable from the rest of the power supply. It will then be routed over here and connected to the other side of the switch. The problem here is this is again really close to the DC switch that will switch the LED. So again I made a small shroud, and this will go in here just like that and separate all of the metal from the switch to the metal from the DC switch that switches the LED. So they are now completely separated by a piece of cardboard. This adds additional protection. And here I've got a small cutout for one of these connectors. I will use these to hook multiple of the LED lights together. The other ones I just have to connect plus or minus accordingly. They don't get a extra power supply. They all will be fed by this one, and this should be fine for I think 4 of these lights. I don't think they use more than 1 watt of power. Now I will go ahead, assemble everything, and as I said, we will take a look at the LED separately. I want to see how much voltage it needs exactly so I can set the DC to DC converter, and I want to see if they get warm and maybe then lower the voltage. Now everything is connected accordingly, and we can take a look at the LED. And right away I have a problem. Both cables are red, so I don't know which lead is for positive, which is for negative. So I have to figure that out, and I'm going to use my lab bench power supply, and I should probably go to a very low current setting and a very low voltage setting. I think I start at 2 volts and go in 100 millivolt steps up. Let's see. Power on the power supply. We are currently at 2 volts. Go plus 100 millivolt, 2.2, 2.3, 2.4, 2.5, 2.6, and there we go. So this is the LED. We can see all 8 individual lights at 2.6 volts, 2.7, 2.8, 2.9, and 3 volts. This is the maximum voltage AAA batteries can supply, and we have a slight voltage drop, so I should maybe give another 100 milliamps, and we're almost spot on 3 volts. So one LED consumes 300 milliamps, and my power supply can deliver 5 watts of power. 300 milliamps times 4 is 1.2 amp at 3 volts. That's totally fine. So one USB charger can supply enough voltage for 4 of these lights. Now I have to remember which lead is for what, and just, oh, that's toasty. Okay, so at 3 volts it gets really, oh yeah, that's, I think, too much voltage. I should maybe go lower, go for 2.8 volts. The thing is, the batteries do deliver 1.52 volts. I tested them, so 3 volts should be fine, but it's really hot. Maybe I should step it down a bit. Well, guess what? They are so cheap, and if one dies, I just replace it with another one. I can't just use the switch part, so I'm not going to bother with that. I will set the DC to DC converter to 3 volts, and that should be fine. Finally, I'm done with this modification. It took a lot of time to get everything together and to fit everything inside of this small enclosure. Such a project is really interesting, but it takes a lot of planning. And what we got here is now the LED with a USB power supply inside a DC to DC converter. I've got an indicator LED that I installed off camera between the last take and this one. We got the main switch, power lead for mains voltage, just a 2-pin power lead, and I got a separate connector where I can hook several of these parallel to each other, but the other ones will not have the power supply inside, so just modified to run on DC. This will handle all the lights, and I plan to use 4 lights. This is how it looks now. Everything fits inside, and I will now take it apart and explain a bit further. I have to remove the top cover very carefully. The LED is directly soldered to the output of the DC to DC converter. I've got the LED directly soldered to the switch and the DC to DC converter. So this is how it looks from the inside. We have a 2-phase mains cable going in, one phase directly connected to a USB charger, the other phase going this way to a main switch, and through the switch back to the power supply. The power supply is partially in the battery compartment over here in this area. I have one shroud over here to protect the power supply from the other mains cable that goes to the switch. Here I've got another shroud that protects the secondary side of the power supply and the DC to DC converter from the mains cable. The USB power supply and the DC to DC converter are connected together, and currently I have soldered a indicator LED directly to the output of the converter. Same goes for the main light LED, which is also connected to the DC switch. And we got another shroud over here to separate the DC switch from the AC main switch. And obviously the 2-lead connector for the other lights is also connected to the output of the converter. Now let's go ahead and test the unit. To be extra safe, I will run this modified LED off of my safety outlet. It now has a power supply inside, and whenever you power on such a project for the first time, anything could happen. And the safety outlet has a really small fuse, it will blow really fast, and an emergency stop button. You never know what could happen. So I will now turn it on, and oh, we see a blue light. It was already switched on, so let me turn it off first. It still lights up. I think that's the capacitor is dying. Now it's gone. So it's plugged in, it's not on, nothing happens. Let's turn it on. We have a blue indicator light, that is normal. And let me tilt it a bit this way and turn on the LED, and it lights up. So the LED seems to work, and not anymore. Something happened. I don't know what. Holy, I thought I messed up, but I didn't. It was just a bit of glue between the DC contact points, so I had to remove the glue, clean it up a bit, and now it works reliable. I can switch it on and off as many times as I want, and I'm really happy how it turned out. And if you like this project, please leave a like, comment down below. But other than that, thanks for watching, and see you next time. Bye!